In today's class, I want to bring up logarithm. To cover logarithm, firstly, you must need to understand the power rules, that means indices, because log is the inverse method of presenting indices. In my previous video, I just completed the topic indices, so I am giving you the link below and please try to cover that. Now let me explain you with some examples. Say 4 power 3. 4 power 3 equal to 4 into 4 into 4. That means 4 3 times multiplied by itself. And we know 4 power 3 equal to 64. This is an exponential expression and this can be written as log 64 base 4 equal to 3. Now you see these two expressions are same but differently presented, and this logarithmic expression can be said as I am writing here log of 64 to the base 4 is 3. Log of 64 to the base 4 is 3, and that means we can say in this way that 4 raised to power what? 4 raised to power what? 4 is the base and raised to power what to get 64. The power of the base, the power in log, the power of the base will be the answer. Here the power is 3, that means log of 64 to the base 4 equal to 3. The power will be the answer in log. So after this discussion, we already understood that log is an expression that tells us the given base raised to which power to get the given number. The given base raised to which power, that means 3 raised to which power to get the given number, that is 64. If we place a formula with variables, it stands like if a power x, I am writing here a power x equal to n, then log of n to the base a equal to x. N is the number that will belong to log, a is the base, and x will be the answer in log. But here are some conditions with the base, that a, that means the base, writing here, the base will always be greater than 0 and a cannot be equal to 1. Now I am going to solve few more examples to make sure that you can take in log easily. So if I asked, number 1, if I asked that log 81 to the base 3 equal to what, then what we have to do is we have to find out the power of 3, that 3 raised to which power to get 81. So here 81 equal to 3 into 3 into 3 into 3. 3 4 times multiplied, that means 4, 3 power 4. 3 raised to the power 4. That means in log we know the exponent of the base will be the answer. So log of 81 to the base 3 equal to 4. See how easily solved. Here is another one for you. Another one, log of 10,000, I am taking a big number here, 10,000 to the base 10. Say log of 10,000 to the base 10 equal to x. Now we should find the value of x. So we know we can write here 10 to the power x equal to, because this is the exponent of the base, 10 to the power x equal to 10,000. Here 1 2 3 4 4 zeros here, that is 10 to the power 4. That means x equal to 4. So log of 10,000, we can write log of 10,000 to the base 10 equal to 4. I am doing another one for you. Log of 5 to the base 25 equal to, say, log of 5 to the base 25 equal to what? Here the base is greater than the number, so we should go for the root. That means, see, 25 equal to 5 square. So 5 equal to root over 25, and in terms of power we can write 25 to the power half. So 25 to the power half, 25 is the base raised to power half to get 5. That's why log of 5 to the base 25 equal to half. Another one I am solving, that log of 1 to the base 5 equal to, say, x. Here log of 1 to the base 5. We know from power rules that any non-zero base raised to power 0 equal to 1. So any non-zero base raised to power 0, that means 5 to the power 0 equal to 1. So log of 1 to the base 5 equal to 0. The answer will be 0, because 5 is the base, 5 raised to power 0 equal to 1, and that is how it is doing. So I am showing you different examples from different angles here to make sure that you can understand everything. Now let me show you some negative powers now. Some negative powers, suppose we have log of 1 over 10. Suppose log of 1 over 10 to the base 10 equal to x. Since 1 over 10 equal to 10 power negative 1. In this case, there is a rule we learned that the base, any base raised to a negative power, any base raised to the negative power will become the denominator of the fraction. That's why 10 to the power negative 1 here, 1 over 10 equal to 10 to the power negative 1. So 10 is the base, 10 to the power negative 1. That means x equal to negative 1. So log of 1 over 10 to the base 10 equal to negative 1. Here is another for you. Log of 1 over 64 to the base 8 equal to what? So 1 over 64, we know 1 over 8 square equal to 8 power negative 2. Here is the same story like before, 8 power negative 2. So 8 is the base raised to negative 2 to get 1 over 64. That's why log of 1 over 64 to the base 8 equal to negative 2. You see, log is following the indices rules. That's why I mentioned that you have to cover indices properly to get across the log. At last, I want to solve an example to find the base. That is, if we have log of 16 to the base x, here the base is missing, equal to 4. X is the base and it is missing. We have to find out the value of x. So we can write x power 4 equal to 16, because 4 is the exponent of x. So x power 4 equal to 16, and then x equal to 4 root of 16. We know 16 equal to 2 power 4, and then 2 power 4 over 4, then it is 2. So the base is 2. Therefore log of 16 to the base 2, because x equal to 2, equal to 4. Now viewers, today I have shown you the basic concept, and in my next video I will show you rules of logs. If you like my channel, please do like and subscribe, and please stay tuned.